All right, so over the next couple days, you're going to be talking about how patterns in the real world can actually be turned into algebraic sentences and algebraic functions. Okay, so today in this video, we're going to talk about how to take functions and patterns we find in the real world, plug them into a table, and then turn that table and those points into a graph on the coordinate plane. So we're going to be talking functions, tables, and graphs. So if you take a look, all right, I've written a rule for what's happening to x to get to y. And the rule is 3 less than twice a number. All right, so you have to go ahead and translate that into an algebraic sentence. So 3 less than twice a number. I'm going to have to start with twice a number. So that's 2x. And then, of course, 3 less than that is minus 3. So I've now written my rule as a function into the table. And now all I have to do is take my x values from the table, plug them into the function, and get a y. So take -2, plug it in for x. 2 times -2 minus 3. And you can pretty much do that math in your head. If you have to work it out on a piece of paper, that's fine too, or even plug it into your calculator. But 2 times -2 is -4. And then minus 3, you're going to get -7. So now you have an x and you have a y. So go ahead and write it as an ordered pair. The x first and the y second. And then all you have to do is do that for every other number in your table for x. So here we go. 2 times -1 minus 3. That's -2 minus 3. That's -5. And my x coordinate is -1. My y is -5. Moving on, 0 times 2, whoops, there goes Mr. Heenan, right, wrong thing. 2 times 0 minus 3. Well, we all know that the 0 property of multiplication says that 2 times 0 is 0, and then minus 3 is -3. All right, so your coordinates here are 0, -3. Continuing on, 2 times 1 for x. Minus 3. 2 times 1 is 2. Minus 3, you get -1. Your coordinates are 1, -1. And then last but not least, 2 times 2 minus 3. 2 times 2 is 4. Minus 3 is 1. So my last coordinates are 2, 1. All right, so I've taken the rule, I've written it as a function, I've applied it to a bunch of x values to get y's, and I've written them as ordered pairs. Now you may remember from last year, what do you do with ordered pairs? You go and you graph them on an xy coordinate plane. Obviously the x and the y, if you want to go and label them again, just to remind you, this line here is x, and the vertical line is y. So you just need to remember how to plot points. So my first point is -2, -7. So that means I'm going to count 2 to the left from 0 for my -2x, and then go down -7. 4, 5, 6, 7. And my point is going to be somewhere about here. Now on your coordinate planes, you can be much more precise and exact than Mr. Heenan can be, but I'm doing the best with what I got. So that's my first point, -2, -7. My next point is -1, -5. So that's 1, 2, 3, 4, 5 down. My next point is 0, so I don't move left or right, -3. Down 1, 2, 3. Then my next point is 1, -1. So that's going to be 1 to the right and then 1 down. And then my last point is going to be 2, up 1. So to the right 2 and up 1, which would be right about here. Now, if you connect those dots as best as you possibly can, you're going to see that it is a straight line. Okay? Most of the time, for now, we're going to get straight lines when we go to graph our points. Okay? Because we're going to be doing functions that are linear, that are straight lines. So that's it. If you have any questions, come ask us. Any one of the math teachers can help you out. All right, we're going to be using this daily, so get used to it, practice it, get used to plugging things in and solving on a table. See you next time. I have no idea if my head was even in. I can.